Alright, we're going to continue with 1996 AB1, and we're already on to letter D, but I do want to make a few comments before we get started. And the first thing is that because we're looking at the graph of the derivative of f, we're going to look for different things than we would in a graph of a function. For example, if we were looking for a min or a max, let's say part A asked us for the relative maximum. Well, obviously, if we were looking for a relative maximum in the original function, then we would be looking for that. However, because we're looking at the graph of the derivative of f, we're looking for where the function, where the derivative changes from positive to negative. And so instead we're looking for that point on there. Now the same thing is going to happen if we were looking for concavity in the original function. We're not going to look at concavity at the concavity of the first derivative. So for example, if I were looking for where this function, where the derivative were concave up, obviously the derivative would be concave up in those two places and would be concave down in the others. But we're not looking for where the first derivative is concave up. We're looking for where the original function is concave up. And so I'll clear some of these markings out of the way. Instead, what we're looking for is where the first derivative is increasing, because the second derivative tells us about the increasing or decreasing of the first derivative. And so if I find where the first derivative is increasing, I'll know where the function is concave up and where the second derivative is positive. So before I start in part D, it asks me to suppose that f of 1 is 0. That gives us a starting point. In the xy plane provided, we want to draw a sketch that shows the general shape of the graph of the function f on the open interval from x equals 0 to x equals 2. So I'm just going to make some notes then about what's happening in the original function based on what I can see in the graph of the first derivative. Well, in the interval from -3 to -2, the first derivative is positive, and so the original function is increasing. The next thing I know is that the slope of the first derivative is decreasing, or the first derivative is, even though the first derivative is positive and the original function is increasing, but the first derivative is decreasing, so that means the second derivative is negative, and so it's concave down in the original function. So the function is increasing, but it's concave down. And that might look something like the curve I've drawn over to the left there. Increasing, but concave down. Alright, then let's go on to the next interval from -2 to -1. Here we note that the first derivative is negative, so the original function is decreasing. And second, we note that the first derivative is decreasing, so the second derivative is negative and it's still concave down. And if I were going to draw a sketch of a curve that is decreasing and concave down, it might look something like that. Now you should note that when the original function went from increasing to decreasing, we had a max there. Alright, next, from -1 to 0, first derivative is still negative, so it's decreasing. So the original function is decreasing. However, because the slope of the first derivative is positive, the second derivative will be positive, and the function, original function, will be concave up. And a curve, segment of a curve, would look something like that, decreasing but concave up. In the next segment from 0 to 1, it's still below the x-axis, so the first derivative is negative, the original function is decreasing, and the slope of the first derivative is positive, so the second derivative is, so the slope of the first derivative is the slope of the first derivative is positive, so the second derivative is positive, and the original function is still concave up. In the next segment, the derivative is negative, so the original function is decreasing, and the slope of the derivative is negative, so the second derivative is negative, and the original function is concave down. And the graph would look something like this. Alright, we'll finish this up and we'll go on to the graphing in the next video.